Hello everybody, welcome to today's remote learning lecture. We're going to be covering sampling. Now, I said at the end of last lecture we were going to spend about 20 minutes at the beginning going over outliers and cleaning data. So I'll just get that PowerPoint up. These were the questions that I wanted you to have a go at. If you've already done these, then you just got 20 minutes where you can do whatever you want, a cup of tea, whatever. At about 1:50 we're going to be carrying on and doing a new topic. We're going to be looking at sampling. So what I can do before we go through these questions is I can just do a quick recap of everything we've done before, just so it refreshes your memory, and then I'll leave you to it. If you've got any questions in the next 15 minutes, then please let me know. Okay, so the idea of cleaning data is that we're looking for outliers and we might want to remove them depending on the context of them. So there were two definitions we used, two methods we used to find an outlier. The first one was that an outlier is any data point more than 1.5 interquartile ranges away from the nearest quartile. So if we took the interquartile range and moved it to the right past the upper quartile, sorry, I'm making a mess of this. I'll show the example. Okay, so in the example here, we had an interquartile range of 8, and the upper quartile was 17, lower quartile 9. So if we take the lower quartile and subtract 1.5 times the interquartile range, that would get us to -3. So there were no outliers at this end. And if we take the upper quartile 17 and add on the interquartile range 8, we get 29. So there would be an outlier at this end. Second definition we had of an outlier was it's 2 standard deviations either side of the mean. So if we do the mean plus or minus 2 times the standard deviation, that will tell us our cutoff point, and if we get anything outside of that, then that means it's an outlier. Okay, so about 15 minutes then. Give you some chance to have a go at these questions. Please get in touch by email if you want any help with any of them. I'll write my email address at the bottom. Okay, so I've been asked a question about the extension one. I'm just going to go through question 9 part A here to do with standard deviation and range of this data. Okay, so we're told that the standard deviation of a set of data is 9 and the range is 50, and we need to prove there's an outlier in this set. Now, it doesn't tell us what the mean is, but we don't actually need to know, as you'll see, provided we know the range here. Now, remember, one of the definitions of an outlier is x bar plus or minus 2 sigma. Anything outside of this region is an outlier. Okay, so if you think about drawing this on a line, let's say this line represents our data. Okay, this is the smallest value, and this is the largest value. So x bar could be somewhere, anywhere in between here, probably somewhere near the middle, but we don't really know. We don't need to know. Okay, so if you imagine drawing another line on here, we know that from here to here, that's 50. And if you think about having x bar and then 2 sigma in that direction and 2 sigma in that direction, the range from here to here would be 4 sigma. Just see if I can move that onto somewhere on my page a bit more in the middle. Okay, now we know that 4 sigma is going to be 4 times 9, which is 36. So if you imagine this bit here, 4 sigma, let me just tidy up that sigma like that. 4 sigma in here is only going to be 36. And so there's going to be data either side, or if it's further to one end, then there's going to be more data at one of the ends, because we can't get this region to cover the whole 50 here. So you wouldn't necessarily need to draw this diagram to answer the question. This is kind of just to illustrate the point. What you would need to say is that since 4 sigma, which is 36, is less than 50, there must be an outlier, at least one. So we can't get all of the data to lie within 2 sigma because the data stretches across a distance of 50 and our outlier region only stretches a distance of 36. Okay, we're going to move on to sampling now. Then welcome if you've just joined us. So sampling is another part of the statistics branch of the course, and in this lesson we're going to be looking at various different methods of sampling. Now, this is quite different to a lot of the maths lessons you'll do throughout the year, where you'll be learning about methods and procedures and learning how to apply them. There's a lot of facts involved in sampling. Now, what I would suggest you do is not write down any notes while I'm going through the first bit. I'm going to go through it quite quickly to start off with, and you've still got the PowerPoint. If you want to go back and make notes, you can. What I'm going to suggest though is once we get to a certain point, you might want to make some index cards with all of the key facts on, because essentially what you need to do is learn these key facts first, and then once you know the key facts, you can apply them to the different kinds of exam questions you might be asked on them. But it is a case of you do have to memorise certain facts about these different kinds of sampling methods, some of which you might already know from GCSE. So we'll start off with a little bit of terminology that we're going to use throughout the lecture. So we're going to define a population first of all as the whole set of items that we're looking at. So everything that's relevant to what we're doing. So a population could be of a country, or it could be all of the bags of crisps in a supermarket, something like that. It doesn't have to be people, it can just be a whole set of things. Okay, and a sample is a subset of that population, and the idea is that we want those samples to be representative of the whole population as much as we can within reason. A key term you may not have met before is the idea of a sampling frame. So a sampling frame is simply a list of everyone or everything that is in what we're calling our population. Okay, we're quite often going to refer back to a sampling frame, so try to keep that definition in mind. It's just a list of everything. So within a sample, each individual little thing we'll be referring to as a sampling unit. Okay, right, so we're going to have a look then at the difference between taking something called a census and taking a sample instead. So a census is where we collect data from the entire population at once. Now, if we're talking about the population of a country, we have a national census which is done every few years. It collects data about practically the whole population. There are a few advantages and disadvantages of each. I want you to think for yourself for a minute about what they might be. I'm going to reveal that. I'm just going to give you 1 minute to have a think about this. When might you want to use a census? And when might you want to use a sample? Okay, so hopefully you've had a think about that then. So the first advantage with a census then is we're asking everybody, which gives us completely accurate results for whatever we want to find out. However, the problem, and there are quite a few of them with doing a census, is it takes a long time to collect data from everyone. We can't do it when testing involves destruction. We'll look in the next example at what we mean by destruction. We'll give a nice clear-cut example of that. And depending on the circumstances, you might end up with a large volume of data that you have to process, which might be expensive. It might be time-consuming as well. In terms of a sample then, they're cheaper, quicker, and we don't have to crunch as much data. The disadvantages depend on how effectively you're able to sample things, but you might not get accurate data. Your sample size might not be big enough to represent everybody that you might think about. Okay, so let's look at a typical kind of example we might need to do then. So we've got a supermarket wants to test the delivery of avocados for ripeness by cutting them in half. Now, first of all, we're going to think why the supermarket should not test all of the avocados in the delivery. Well, kind of got a common sense answer here. If you're testing them by cutting them half, you're not going to be able to sell them anymore. So the testing is destroying them, and that's what we said was one of the disadvantages of doing a census. In some cases, if you want to do a census, you'd be destroying everything you were trying to measure. And part B, the supermarket tests a sample of 5 avocados and finds that 4 of them are ripe. They estimate that 80% of the avocados in the delivery are ripe. Suggest one way that the supermarket could improve it. Well, the most obvious way is you simply have a bigger sample. The larger your sample, the more likely you are to get accurate results for whatever you're trying to find out. Okay, so we've got another one here then. Have a think about the answers for yourself, and I'll go through them in a minute. Okay, so in part A, we're thinking about the sampling frame used for a large school that's got 1,800 pupils. So an obvious sample frame is a list of all the pupils in the school, which we generally have. We call it a register. And then you could ask, would we use a census or a sample? Well, it's not beyond the realms of possibility to ask every single person in the school how they travel. But it might be quite difficult to chase people up, particularly if you're trying to get every single person to answer the question, and the people that you don't get answers for are probably going to be a certain subgroup of people that you might want to make sure you include in those results. So you're more likely in this case to take a sample, and you would, as much as possible, try and make that sample representative of everybody in the school. So next thing we're going to look at is what size should our sample be in order to give us a good trade-off between reliable data and not taking up too much time and costing us too much to create. So a large sample is going to take time, money and effort, but it's going to more accurately reflect the real results. So if we're doing for a small population, if we take a sample of 5 to 10%, that's normally going to give us reasonably accurate results. For larger populations though, we're looking at taking a sample of the size square root of n. So if you wanted to do, for example, a sample with the whole of this country, and you wanted to find out how many people should we ask to get a good idea of what we want to find out, then you would just square root the population size. So a typical example, if you had a population of size 400, your sample size would be the square root of 400, which is 20. Okay, next up we're going to look at 3 different methods of sampling and look at some of the advantages and the drawback of each method. Okay, so in the next 3 methods we're looking at, you're going to need to have a sampling frame for all of them, and they all in some way involve random sampling. Okay, so the first one we're going to look at is called a simple random sample, and in a simple random sample, every possible person or thing has an equal chance of being selected. So we'll keep coming back to this picture where we've got some white people, green, blue, grey and orange. Doesn't matter what colour the person is, they would have an equal chance of being selected. When you do random samples, you quite often get people selected next to each other. Okay, they don't have to be evenly spaced apart. They're just completely chosen at random. So how do we go about taking a random sample? Well, the first thing we need is our sampling frame, our list of everything. You cannot do a random sample if you don't have a list of the entire population. And this is one of the main drawbacks when you try and do random sampling in the real world. If you don't have a list of everything, you simply can't do a proper random sample. Okay, once we've got our sampling frame, we give every item on the list a number so that we can identify which ones are which. And then once everything's got a number, we use some form of a random number generator to choose items that we want. So if we wanted 20 people and we got a population of 1,000, we would number everyone 1 to 1,000, and then we would pick 20 random numbers from a list. Okay, another alternative to generating a random number is you could do something like names in a hat, which is called a lottery sampling. You could pick the names out of a hat each time. Okay, what I'd like to do, it's not really relevant to the course, but it can be quite useful for this kind of thing. I'm going to show you on your calculator how you can generate a random number. Okay, so the instructions are on the screen, but I'll just go through it as well. So if we're on our main menu, go into mode 1, the normal calculator mode, and you press Option F6, and then you go into the probability one, and next to your NCR button, which you should be familiar with, is a button called Rand. If you press that, you get a few different choices. The one we're going to use is int, stands for a random integer. It opens as a little bracket, and we need to put two numbers into that bracket. The first number is the lowest number that we could possibly get. The second number is the highest. So if I enter 1,30, close that bracket and press equals, that will generate me a random number between 1 and 30. So 20 in this case. And if I keep pressing equals, I can get as many numbers out of that list as I want. I could change these numbers. I could, for example, do a random number between 5 and 10. And I could get some more like that. Now, for all intents and purposes, you can treat these numbers as completely random. They're not actually random numbers. There's something called pseudo-random numbers, because your calculator cannot physically just generate a random number. It has to have some kind of calculation that gets these numbers. But for all intents and purposes, for anything you really want to use them for, they're perfectly valid as random numbers. So that's simple random sampling then. Advantage of it is if you do a big enough sample, you generally would get a bias-free sample, and it's easy and cheap to implement provided you have that sample frame. And in the sample, everything has an equal chance of being selected. So there are some disadvantages though, and the biggest one is, as we've mentioned a couple of times, you need a sampling frame in order to do it. And also, it may not be suitable for large population sizes, and that is related to not being able to get a sampling frame. Not necessarily the only reason though. It might be that even if you do have a sampling frame, it's difficult to access every item in the whole population. For example, if it's people, it could be difficult to obtain a sample where people live in remote areas or something like that. Okay, here is a question then, which is wanting you to write out how you would do a random sample. So I'll display the answer in a minute. I just want you to have a think for yourself though, and just jot down some rough notes. This is a past exam question that was worth 3 marks. So what 3 things would you do in order to create a random sample in the context of this question? So a minute ago I went through the process of just doing a general one. Try and talk about it in the context of this example. So this example is about girls and boys in a school. Okay, so I'll give you 1 minute just to jot down some notes, and then I'll go through some of the details of it. Okay, so the first thing we need to look at doing is obtaining a sample frame and using it to give everybody an identifying number. Next up, we need to use a random number generator to select people. So in this case, we've got 120 people. So we're going to generate 15 different numbers between 1 and 120. It is really key in here when you're giving an answer to this kind of question, you make it clear that you're not just selecting 15 numbers, you're selecting 15 different numbers. So if you were generating the numbers on your calculator and you were going between 1 and 120, and in your sample the number 6 came up twice, the second time it came up you would discard it, so that you end up choosing 15 different numbers. And the numbers that you choose, you match them up to the sampling frame, and they are the people that become your sample. Okay, so they are the 3 things that you would have to mention to get the 3 marks in this question. Okay, similar kind of question here then. Okay, a student wants to take a sample of students from his college. He's got the students numbered from 1 to 478, so he set it up and he uses a random number generator on his calculator, which can generate the 3-digit numbers from 001 to 999. And these are the first 10 numbers he obtains. And in this question we need to suggest which will be the first 4 numbers in his sample. So it's not a trick question, but it does catch a couple of people out. Just go through the list from left to right and see what would the first 4 numbers you choose. Okay, first up then we could look at the 237. That's perfectly fine, so we'd choose that. Then we'd look at 155. That's okay, we can have that one as well. 623 is up next. We wouldn't choose that, it's too big. It's bigger than 478, so we'd cross that one out. 078, that's fine, we could go with that. 523, that's fine, we could go, oh sorry, making a mess of that. 523 we couldn't use again because it's too big. 078, we're not going to use that because we've already used it here, so we'd cross that one out. And then 003 is okay. So our 4 numbers are 273, 155, 078 and 003. Okay, second method up then is systematic sampling. Okay, so again we need a sampling frame for this one, but what we're going to do, rather than picking people out randomly, we're going to select the first person randomly, and then after that we're going to choose every so many people. So we might choose every 5th name on the list or something like that. So if I drew the picture, it kind of looks a bit more uniform, like so. So here's how we'd go about taking a systematic sample. First thing we do is get our sampling frame, and then for the first item we have to randomly select it. After that we would choose items at regular intervals. So we might say, right, we're gonna have the numbers 1 to 5, and we're going to do a simple random sample to select the first one, which we just looked at. And then after we've selected the first number using a simple random sample, we'll choose every 10th person or something like that. Okay, now it suffers from some of the same advantages and disadvantages of simple random sampling. It's generally quite easy and cheap to implement, and it can be used for large populations as well. Disadvantage again, you still need a sampling frame, because if you don't have a list of all the people, you can't use it. The big thing you need to look out for is you need to make sure that the sampling frame that you use has things in a random order. Because if you've got a list of people, I don't know, let's say you were doing a list of students and you'd got grades for each of the students, and you put them in like order of grade to start off with, and then started choosing every 5, you wouldn't be doing a systematic sample starting from a random sampling frame. Okay, so here is a question on how we would do a systematic sample. We've got a telephone directory, contains 50,000 names, and we want a sample of 100 names from the directory. So we're going to go through that method that we just talked about. We have to do a little bit of maths in order to get there. I want you to have a think about this for yourself. So if we are choosing 100 names, the first thing I want you to think about is how big would the jumps be in between names. Do a little calculation, make sure you've got that, and then see if you can write down a little method. It's only worth 2 marks, so don't write too much. How would you go about doing this sample? Okay, so the calculation you'd want to do is you take the amount of items you've got in your population, 50,000, divide it by 100, that gives us 500. That means we want to choose every 500th person. Now, before we start going every 500th person though, we have to select a first person. So the first thing we've got to do is we've got to randomly select a number between 1 and 500. That's going to represent the first person. Once we've got the first person chosen, we then choose every 500th person, counting on from the first item we selected. So choose the first item using a simple random sample, and then after that choose the people systematically. Okay, third method then is stratified sampling, probably another one you've met at GCSE. So in a stratified sample, we first of all think about can we divide the population into subgroups. Could be something like boys and girls if it was a sample of people. If it was a sample of vehicles, you might have cars, vans, lorries, something like that. Once you've separated them into groups, you choose the proportion of people you choose from each group is proportional to how big that section of the whole population is. So in the example here at the bottom of the page, we've got 4 rows of blue people, 2 green, 3 grey and 1 orange. And so when we decide to choose people, let's say we did a sample of 20%, we would choose 4 blue people, 2 green, 3 grey and 1 orange. So we do a little bit of maths to figure out how big each sample size will be in this part. And then within each group, you have to choose people randomly. So you split it into groups, you decide how many you want from each group, and then within each group you have to do a simple random sample. Now that random part is key to this method, because there's another method we'll look at later where you split people into groups but then you don't choose people randomly. Okay, so make sure when you're doing stratified sampling you are choosing the people in the subgroups using a random sample. Okay, so stratified sampling, we've talked about the steps. Key advantages is that it accurately reflects the population structure, provided you set up your group sensibly to start off with. So you've got to make sure that you're careful about the groups you choose, otherwise that becomes a disadvantage instead of an advantage. And the second one is that within those groups we're choosing the right amount of people. So if we've got, for example, twice as many boys as girls, we would choose twice as many boys in our sample as well. However, disadvantages, you've got to come up with the groups, and if you don't come up with sensible groups, it's going to mess up your data. And again, we still need a sampling frame in order to do this, because once we divide up into proportions of how many we want, we have to choose people randomly from in them groups, and we can't do that if we don't know who everyone is. Okay, so a little bit of maths involved in this one. It's a typical kind of GCSE question, this is, I think, as well. So, school is made up of 250 girls and 150 boys, and we want to take a sample of size 80, stratified between boys and girls. Calculate the number of boys and girls that should be in the sample. So, I'll give you a couple of minutes to have a go at the calculations required to choose them now. Okay, step 1 then is find out how many people we've got altogether. So 250 add 150 is 400. Then we say what fraction of our sample will be each one of these. So if we want the number of girls chosen, we're going to do 250 out of 400, that's the proportion that are girls, multiplied by our sample size, and that gives us 50. Similar thing for boys, so 150 out of 400 are boys, multiply that by our sample size, that gives us 30. Okay, if these numbers had ended up being decimals, we would have to round up and down appropriately. And then at the end, just check that the numbers add up to the sample size that you want. Okay, just one more quick question on that then. You can check your answer in the PowerPoint when you've done. This one we're stratifying by age rather than sex. Okay, so have a quick go at this one, see how many you'd choose for each. Okay, here are the calculations you might do for this one then. So you should end up with 16 girls from year 7 to 9, 11 girls from years 10 to 11, and then 3 girls from the sixth form. It's always a sensible idea, particularly if there's been any rounding involved, to add these numbers up at the end. 16 add 11 add 3, make sure they add up to your sample size, in this case 30. Okay, so those 3 methods that we've looked at, they all involve some kind of random sampling. However, there's a bit of an issue with using those methods in the real world in a lot of the time. I'd like to consider the following example. So imagine you want to find out whether in the UK being left-handed affects IQ. Are people who are left-handed slightly smarter or not as smart as people who are right-handed? We think, is there an obvious problem with the 3 methods that we've looked at so far if we wanted to do a random sample? Well, the answer is yes, because all 3 of the methods we've used so far require a sampling frame in order to do them. And we don't really have a sampling frame for this. We don't have a list of every single person in the UK and whether they're left-handed or not. So it'd be very difficult for us to actually do one of the methods we've done so far. So we're going to look at some methods now which are more likely to be used in the real world, but the trade-off for that, by not knowing the sampling frame, is that you're more likely to introduce bias into your results. So the first one, and I suppose the worst out of all of them, is something called opportunity sampling. Basically all you do is you check and you ask the first few people you find. So if we've got lots of people, we might, for example, stand outside McDonald's and find out people's opinion on fast food, and we'd ask the first few people who came out the door. Now, quite obviously, if we did that, we're introducing a bias based on where we're standing, which is one of the reasons it's quite difficult a lot of the time to use opportunity sampling effectively. Some benefits though: it's very quick to do and organise, and you don't need a list of people, you just ask the first ones you find. But if you just do opportunity sampling on its own, there's a very high chance that you're going to get a biased sample. Okay, so moving on to another method to maybe slightly improve upon that is quota sampling. Now this has a lot of links with stratified sampling. So as we go through this method, see if you can make links with how stratified sampling works, but also see if you can notice the difference between the two as well. So in quota sampling, we split the population into groups based on factors relevant to whatever we're interested in finding out. So we might split people by gender, we might split people by age, or anything like that. But then once we've split them into the groups, the way we would choose people from in each group is using opportunity sampling. So we would ask the first few people we find in each group until we've got enough people. So a typical example, imagine we're stood at the side of a road and we want to find out if people who drive red cars drive too fast. First of all, we'd need to know roughly what proportion of people drive red cars. Maybe it's a quarter of the population. We'd ask a quarter. As the cars go by, we'd say we're going to ask a quarter of many of those as we are other colour cars. And then as they go past, we keep ticking off the cars and how fast they're travelling until we've got enough in each category. Okay, another example. Suppose we've got a survey of 20 men and 20 women about whether they use sun cream. Okay, since we want an equal amount of each, we're just going to ask the first 20 men and the first 20 women that we see. Okay, so again, this is another method where we don't choose people randomly, which means the main advantage is that we don't need a sampling frame. We can just sample people that we can find. And it's better than opportunity sampling because we're thinking a little bit about the proportions of people from each subgroup that we want rather than just asking the first people. So that's going to reduce some of the bias, but not all of it. As we don't need a sampling frame and we're still using opportunity sampling, in a lot of cases it can be quick and easy as well, and inexpensive. Okay, but as we're not randomly sampling people, we are more likely to introduce bias even if we try our best to try and reduce it. And we need to be able to still divide people into groups, which could be costly or not accurate. Okay, so a quick question for you to have a go at then. This one's got 7 marks in it, so I'll give you about 7 minutes to have a go at it, see what you think. If you're not sure of an answer for each part, then just put what you think to start with and then move on to the next part. Once you finish this one, if you have got the PowerPoint open, the answer, the mark scheme, is on the next slide, so you can check your answer and award yourself however many marks you think you could get after that. Okay, I'll go through the answer in a few seconds. Before I do though, I just want to go through some of the reasoning you might apply when you're approaching this question. So, first of all, give a reason why stratified random sampling cannot be used. Now, at first glance, it might seem sensible. We've got different proportions of different fish. We want to split them into groups, which we do want to do. But, key word here is random. We can only do any of the random sampling methods, simple, stratified, or systematic, if we have a sampling frame. And we don't have a list of all the fish in the lake. It says there are estimated to be this amount, so we don't even know exactly how many there are, let alone have a list of them. And so we can't do a random sample if we don't have a sampling frame. Okay, various different advantages that you could have for the next part then. I'll leave them on the board for you to read. Okay, and then the final part, we should be looking at using quota sampling. So we've got groups already split up for us, trout and so on, and we just need to choose the right proportions from each. So we've got a sample size of 30, so do the right fraction times 30, we get these numbers here. Remember to round them and then choose your sample. Okay, key thing we need to make sure we write for the last one then is that if we say, for example, if we got 17 trout and then we caught another one, okay, we wouldn't count that one in our sample. We'd throw that one back because we're not interested in having more than 17, and we keep going until we got the right amount of each one. Right, last sampling method then is called cluster sampling. Okay, it's another one where we split things into groups. But this one is when you would be more interested in looking at a particular subset of the whole population. So let's have a look at a picture to kind of illustrate it. Let's say we've split our population into groups. We've got different colour faces here, and then we'd say, right, we're not gonna choose proportions from each that represent each group. What we're going to do, we're going to home in on certain subgroups. We'll say, right, well, we'll ask all the people from the green faces and all the people from the orange faces. Now, the issue with that is you're not getting a representative sample of the whole population. So cluster sampling is not really designed to help you do that. It's designed to help you think about your groups and say, right, I'm interested in what's going on with this subgroup, and I'm going to ask lots of people from that group. Okay, so they are all the different methods we're going to look at. So in a few minutes, I'd like to have a go at some of the questions from the textbook. However, before you do that, as I've not asked you to write any notes on what these are, what I'd like to do is have a think about making some index cards. This is probably a good idea before you have a go at any of the questions. So you've got 6 different sampling methods. Try and get my pen to work. Okay, and for each sampling method there are a few things you need to know. You need to know the procedure, and you need to know advantages and disadvantages. So what I would suggest you do is make yourself a set of index cards. Now there's different ways you can do it, and ultimately it's up to you how you decide to do it. I'll give you an example of a typical card. You might have the front of the card that says, I don't know, systematic sampling, advantages, and maybe you could maybe put disadvantages on the same one. Okay, so that will be the front, and you would see that first, and then on the back you would have the answer. And then in order to help you learn these methods and be able to remember them, you just keep testing yourself on them every so often. You don't have to do it constantly all the time. Every so often just try out, see if you remember what's going on with the cards. The advantage of this is that you're actually having to think about the answer rather than just reading it. And if you just go back and you just make notes on all the different sampling methods, you'll feel like you understand it because you've seen it before, and I've been through it in this lesson, and you think, right, yeah, I get this. But there aren't many people who, just by reading them, will be able to have a good memory of what's going on with the different sampling methods. It's only by testing yourself on them that you're going to start to remember them a bit better. Okay, so what I would suggest you do before you attempt the textbook questions is make yourself a few index cards for each one. Okay, and then the questions I would like you to have a go at are on slide 31 of the PowerPoint. So we've got about 25 minutes left in this lesson, so I'm going to be here until 3 o'clock to answer any questions people have got about anything. If you want me to clarify anything in any more detail, then please just send me an email and I'll do my best to do that. Okay, if I don't speak to you again, have a nice day. I hope you enjoy the rest of the sunshine today, and I'll see you all on Tuesday.